In this video, we'll be going over lowest common ancestor of binary tree. So given a binary tree, find the lowest common ancestor of two given nodes in a tree. So the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. Now, for example, we're given this tree, and then we're trying to find the lowest common ancestor of 5 and 1. So it's located at here, 5 and 1, and we can see that it's equal to 3. So we return the node with the value of 3. Let's go over the dot process. So for each of the node x inside the binary tree, we will want to find P and Q on the left and right subtrees. Now, how can we determine if x is the lowest common ancestor? So there are two cases. So the first case is if left and right are equal to true. This means we have found P and Q in different subtrees. So in this first example, we can see that the moment we're at this node and we are able to find P at the left subtree and we also find Q on the right subtree, this means P and Q are both in different subtrees, then the current node must be the ancestor. So the second case is if we have found P or Q in the left or right subtree, and the current node x is equal to P or Q. So in this case, for example, if this node currently has a value of 1, let's imagine this node is currently Q is equal to 1. So let's imagine this node as Q with the value of 1. If we have found P on the left subtree and the current node is equal to Q, then we know the current node is the lowest common ancestor. Now let's go over the pseudocode. So we're going to create a custom class, Ancestor, to keep track of the lowest common ancestor. Then we're going to create an instance of Ancestor. Actually, there will be one field, which will be equal to node. Then we're going to implement the recursive approach to find the ancestor. Now, what parameters do we need? We need node, the current node we are visiting, and we need P, the input node, and Q, the input node, and ancestor is the helper class to save the lowest common ancestor. Now, what's the base case? If node is equal to null, this means we have failed to find P and Q, so we can just return false. Then in each of the recursive call, we're going to recursively search the left subtree for P or Q, for P and Q. Then we're going to recursively search the right subtree for P and Q. Now, then we're going to create a Boolean variable, current. Now, if node is equal to P or Q, then we're going to set current to true. Now we can go over the two cases. Now, if left and right is true, this means we have found P and Q in different subtrees. This means the current node is the lowest common ancestor. Or left or right is true. This means we have found P or Q in the subtrees. And the current node is true. This means we have found P or Q in the left or right subtree, and the current node X is equal to P or Q. So this also means the current node is the lowest common ancestor. Now we're going to set ancestor.node to the current node. Then we can just return false because we have already found the lowest common ancestor. We do not need to search forward. Now after that, we can return true if left is true, or right is true, or current is true. Now what's the time and space complexity? For the time complexity, we get O of n, where n is the number of nodes. We visit each node once. And our space complexity is O of h, where h is the height of the tree, is the recursive call stack memory. Now let's go over the code. So we're going to create a custom class Ancestor to keep track of the lowest common ancestor. And there will be one field, which is equal to node. It'll initially be equal to null. Actually, there's one more thing. We can return ancestor.node as the result. Now we're going to create an instance of ancestor. Then we're going to implement our recursive approach to find the lowest common ancestor, passing our roots, Q, P, Q, and the helper class. Then we can return ancestor.node. Now let's implement our recursive approach to find the lowest common ancestor, keeping track of the current node, P, and also Q. And then helper class ancestor. Let's go over the base case. If node is equal to null, we have failed to find P or Q. We can just return false. Now we'll first recursively check the left subtree to see if we can find P or Q. Then we'll recursively search the right subtree for P and Q. Now we check the current node, and we'll set it to true if node is equal to P or node is equal to Q. Now we'll go over our two cases. If left and right is true, this means we have found P and Q in different subtrees, so this means the current node is the lowest common ancestor. Or left or right, this means we have found P or Q in one of the subtrees, and the current node is equal to P or Q. This means the current node is the lowest common ancestor. So we can set ancestor.node is equal to the current node. Then we can return false. We don't need to search further. Else, we can just return true if we have found P or Q in the left subtree, P or Q in the right subtree, or P or Q in the current node. Let me know if any questions in the comment section below.